Hey everyone, this is Kevin with Olympus Controls, and today we're going to take a look at Epson Robots Ethernet IP implementation. So our setup includes an Epson VT6 robot. We also have a Compax Logix PLC here. It's a 5380, and the plan is to control the robot from the PLC using implicit Ethernet IP communication. Right now our VT6 has the EIP adapter card installed, and that's as far as we've got. I don't really know where to go from here, so fortunately Epson is usually pretty good about documenting their robots and any options that they have available. So let's go ahead and open Epson RC Plus and let's look at what manuals we have available. Probably this Fieldbus IO manual and this PLC function blocks manual. Let's go ahead and open those. 354 pages. Okay, all right, let's take a look at the other one. 160. Okay. All right, I finished reading through Epson's Fieldbus IO manuals. There are a variety of different ways to communicate with the Epson robot using Fieldbus IO, but since we're using an Allen Bradley PLC, we're going to take advantage of Epson's PLC function block option. Setting up everything is pretty simple. It's effectively a three-step process. Scroll down here, where step one is to configure the robot controller to communicate with the PLC. Step two is to configure the PLC to communicate with the robot. And lastly is to import Epson's AOIs into the PLC project that we can actually use to control the robot. And all of the AOIs here, these function blocks, are actually listed out in this manual. So if we have any questions, we can always reference the manual. So let's go ahead and jump into configuring the Epson robot here. I already have Epson RC Plus open. You'll notice that I have an empty project here that I've named Epson EIP. So let's go ahead and connect to our demo robot, configure those settings. Okay, we should be connected. Let's go ahead and go through the setup process by clicking on Setup, System Configuration. And we'll navigate, we'll expand controller, and we'll navigate down to inputs and outputs. We'll expand that, and we'll click on Fieldbus Slave. This is going to be our I/O size that we're going to set up on the PLC, so we need to keep this in mind. We're going to leave it at the defaults now, but if we needed more or larger byte sizes for some reason, we can change those. But for this demo, the default size is fine. Go ahead and expand the Fieldbus slave and click on Ethernet IP. And the only thing that we actually need to configure here is the IP address. Now, our PLC already has our PLC already has an IP address. So we're just going to go ahead and toss this robot onto the same subnet as the PLC. Actually, I wrote it down here for reference. The PLC is 192.168.100.50, and we're going to go ahead and put the robot on .51 with this subnet mask. All right, and anytime we make a change, we need to click on Apply. Otherwise, we can't navigate to another option. And the last option we need to set is going to be under Remote Control and PLC. Now, if you don't have this PLC selection here, that means that the PLC function block option code has not been enabled on your robot. So keep in mind, you will need an option code for the PLC function block, functionality. All right, from the PLC vendor, let's go ahead and select Alan Bradley, and click Apply. Now we'll get a pop-up here. This is just letting us know that it's going to switch the control mode from whatever it was, which right now it's probably on PC control mode, to remote I/O. This will allow the PLC to actually control the robot. So we'll continue, we'll click yes, and that's it. That's all we need to configure on the robot side. So we can hit close. The robot should, the robot controller is restarting. This will take a few seconds, so I'll go ahead and pause the video here, and I'll pick it up from this point after the robot's restarted. Okay, yep, it looks like a robot has successfully restarted. Let's go ahead and double check those parameters to make sure they've taken effect. In controller, let's look at our field bus slave. Yep. Ethernet IP, that's the IP address we set, and the remote control should be set to Alan Bradley. Okay. Now we can go ahead and move on to configuring the PLC. Okay, let's go ahead and create a new Studio 5000 project. Click on new project here. We'll give it a name. We'll just call it Epson EIP. All this is fine. Click on finish. And we'll give this a minute to create our project. Okay, our project has been created. There we go. And the first thing that we want to do is go ahead and add the robot as a generic Ethernet module. So I'm going to go ahead and right click on new module for A2 Ethernet. This happens to be the module that I'm using to communicate with outside devices from the PLC. So we'll right click, new module, and we will search for generic Ethernet module right here. We'll click on create, and we'll give it a name. We'll just call it Epson. The COM format, the recommended COM format is integer. And here we're going to put the IP address of our robot, and if we recall, 192.168.100.51. Now the assembly instance for the input is 100, 150 for the output, 1 for the configuration. The size is 128 bytes. Each byte is 8 bits, so at 16 bits, that would be 64 for the size of the input and output, and the configuration stays at 0. All right, we'll go ahead and click OK. All right, we see here our module has been created. We can actually go online to verify that the status of this is running, and there's no major faults. So we'll go to Applications, Download. And we'll give this a minute to download. All right, the project has been downloaded, and we can see down here that the status is running. Let's import the AOIs. And the AOIs are actually found within the Epson folder. Let me go ahead and pull it up here. Right here. So under C drive, Epson RC70 and Field Bus, you'll see this folder called Function Block Libraries. So I've copied this folder onto the PC that's running the PLC software, and inside this folder has the Allen Bradley AOIs that we're going to be using within the program. So click on add-on instructions, we right-click, and then import add-on instruction, and we want to find spell_all. And this will actually import all of the spell plus commands that are inside this folder. Click on open. And this will take a minute, so we'll let this do its thing and pick up once it's done. Okay, once all the add-on instructions have been loaded in, verify that there are no errors here, and we look good. We'll just click OK. And it will start importing the AOIs. And again, this will take a minute. There we go. All the AOIs have been imported. If I scroll up here, I can see that they're all listed underneath assets and add-on instruction. Okay, now we are, minimize this guy. Now we're ready to set up our main program. We're just going to write a simple program that's actually listed in the help menu. We're going to initialize the AOIs and then turn the motors on and turn them off. And to do that, let's go ahead and start setting up our rungs here. So we'll call this initialize switch, and over here, initialize coil. Go ahead and add a new rung. And we're going to drag in the initialize function block. So it's going to be spell_init right here. We'll just drag this guy in, and we'll give it a name. We'll just call it init. And let's go ahead and create a new init. By default, it selects the appropriate data type. We'll click on create. And we'll do the same thing for switch here, our coil here. And the start is the bit that is going to trigger this initialize function block to actually start. And we're going to tie that to our initialize coil up there at the top. The external inputs and outputs are actually the robot here. So when we created this module, it should have created some controller tags up here. We'll have the Epson I inputs and the Epson O outputs. Those are what we are going to use for our ext inputs and outputs. So Epson :I and Epson :O. All right, let's go ahead and add another rung. This will be our motor. Oops, get this renamed. Motor on switch. And motor on coil. And we'll create a new rung wherever the add rung button is. There it is. And here we're going to drag in the spell. You'll start to see a pattern here. We'll drag in the spell motor on. These are all alphabetical order. Drag this guy in. And we'll give this guy a name. We'll just call it motor on. Create this as new motor on with the spell motor on data type. Create. We'll tie the start of this function block to motor on coil. And of course, the inputs are Epson :I, and the outputs Epson :O. And you can kind of see that all these function blocks are going to follow the same pattern. You have a start Boolean, and then you have them tied to your controller tags here. And then whenever the start, where is it? Yeah, so whenever the start Boolean goes high, this function block executes. And we'll go ahead and do one more for motor off. Motor off switch. And motor off coil. And of course, we'll drag in our spell motor off function block. Let's call this motor off. Create. And we'll tie the start bit of this guy to motor off coil. And the inputs will be Epson I, and then of course Epson O for the outputs. There we go. I think we are ready to go ahead and download this project, demonstrate that the motors do turn on and off. We can verify that there's no error output from the function blocks, and go from there. Go ahead and go to download. And we'll give this a minute to finish compiling and download, and we'll pick up from there. Okay, the download was successful. Let's go ahead and scroll back up. And we'll set our PLC into run mode here. Yep, change to run mode. Okay, now if we toggle this initialization switch here, we should see the coil go high. Error bit came on. Okay, guys, I discovered my mistake. I accidentally changed PLC vendor within the robot configuration to none. So I was poking around and I found this PLC vendor option was set to none, so I changed it back to Allen Bradley, and everything is working as expected. I'm not going to edit this mistake out of the video. Hopefully anybody watching this video, if you encounter any similar issues, you know to go back and just kind of double check your PLC vendor here. Additionally, while we were offline and I was troubleshooting, I added some additional spell plus commands within the main routine here. Let's see, so we have our initialize, our motor on, of course, motor off, and then I added a couple of rungs here that move a value of 0 into this pose 0 variable, value of 1 into this pose 0 variable, depending on the state of pose select. And that will fill in this point value here for the spell move command. And pretty much all that does is command the robot to issue a move command to a specified point. And our specified points are 0 and 1 in this case. And we have another rung here that actually executes the move command. So if we did this right, we should be able to select our pose, trigger our move, and the actual robot should move to either 0 or 1. We can go ahead and test that. I have the RC Plus open, and I have the simulator open over here, so we can actually see the robot move. First thing we want to do, of course, is initialize the robot. Well, probably helps if we're in run mode, huh? Let's go ahead and go online and make sure the PLC is in run mode. We'll wait for this to finish. Okay, the project is downloaded. The controller is now in run mode. So if we flip this initialize switch, hopefully we do not get any errors. And we do not. The initialization, the done bit's high, no errors. We can flip that off. Next, before we can actually command motion, the motors do need to be on. Go ahead and turn the motors on. In cycle, it takes a few seconds for the motors to power on and the brakes to release. The motors should be on. And now we should be able to move between points 0 and 1. So first, I'm not really sure of our current location. We're either at 0 or 1, but let's go ahead and turn on the move switch and see if the robot moves to position. Yep. So that was moving to position 1. Let's go ahead and flip our post select switch over here. Now we're writing move to position 0. You see the point down here changes from 1 to 0. We'll go ahead and flip the switch. And now it's moving to position 0. So we have full control of our robot using all of these different spell plus commands. And again, you do have access to the PLC function block user manual, which gives a description and an example on how to use each of these function blocks. And lastly, just to cover all of the changes I've made to the program, let's scroll down here and take a look at this spell reset error and the spell reset. If any error occurs within these function blocks up here, before you can execute another function block, you actually need to reset the error using the spell reset error. And then the spell reset function block will simply reset the robot to an initialized state. Oh, it actually tells you over here. Yeah, so if you click on any parameter, if we click on the, so we're on spell reset right now, and it gives a description right here. So, but if we click on the spell reset error, resets AOI library error state. Okay, and I believe that wraps up this video. So until next time, I am Kevin with Olympus Controls.